Alright guys, let's get going to part 8. Some more work with circles. Here is where we're actually going to put those relationships to work and actually find some numbers. And so let's start off by looking at this relationship again. Remember we have central which is the same as the arc, a circumscribed and an inscribed, and they each have a very particular relationship. The ones that are important is that the inscribed is going to be half the central value, and the central and the circumscribed values have to add to 180 degrees. And so we're going to put that to work here. So we have to find, in this case first, EDF. So it's an arc that starts at E, goes through D, and ends up at F. And so the way we'll work this is to realize that 110 is the only part of the circle we're not using. If the circle is 360 degrees, and we're not using 110 of it, that means whatever we have left for the measurement of EDF has to be the result of this subtraction problem. So 360 minus 110 should give you 250 degrees, and that's to measure that arc. Alright, so here we have an angle. We have an angle that starts at X. Where's X? There it is, X. Okay. Starts at X, goes to U, and ends up at V. So there's a couple of different ways we can work this. One thing is to realize that they're giving us a huge hint by marking these two arcs, which means they actually are the same. So even though we don't have any information about this part of the angle, we do have enough to actually find it. What I mean is this: if you consider the entire arc of the circle being 360 degrees, and then if you take away the 40 degrees that's accounted for there, and then you take away the 80 degrees, which is accounted for here, because remember the central angle and the arc are the same. Okay, that leaves 360 minus 40 minus 80 leaves 240 degrees. Now this 240 degrees, because of the way these are marked to be congruent at the central angle, has to be split evenly over those two arcs, which means that's 120 and that's 120. So to revisit what we've been asked to find, which is this angle, this purple angle, we realize, hopefully we can realize that the arc, this arc and that angle are the same. And so if this much of it is 120 and that's 140, that means this entire arc has to be 160 degrees. And if the arc's 160 degrees, that means that's 160 degrees. Okay. And so the answer to this question is 160 degrees. Okay. Here we have another angle. The angle starts at J, runs into I, and back out to K. So it's another one of those problems where it seems to have like limited information to actually solve it. But that's not necessarily true. We just have to kind of take a close look at what we have. So first of all, let's first realize that this angle and this angle should be the same. And so although we don't have much information on the left-hand side of the circle, if, and this is an if, I can somehow find this arc, I'm in business. Because if I know this arc, I know this angle, and since it's vertical to the one I actually need, they should be the same value. Now luckily, we have a line that goes to the center, which means that diameter can inform this arc. Mostly that this arc has to be 180 degrees. So if we already had 105, that means this much has to be 75 degrees, which means that's 75 degrees, which means that's 75 degrees, and we have our answer. And so JIK is equal to 75 degrees. Why do I write percentage? Alright, another one of the angle game they want to play. Starts at J, runs through K, and ends at I. I'm sorry, it's not an angle, it's an arc. So it starts at J, runs through K, and ends at I. So this is going to be a pretty straightforward one. The only part of the circle we know is 80, and that's the only part we don't need. But if you consider the entire circle is 360 degrees, if you subtract off 80 of that, you should end up at, what is that, 60 plus 20, so it ends up at 280. Okay, so that means the arc we're looking for has to be 280 degrees. Okay, here we have some circumscribed angles. So recall the relationship of the circumscribed angle is that this angle, the central, and that have to add to 180. And so if we want 100, if we want x, we can just set up that relationship and solve it. 133 degrees plus x degrees is equal to 180 degrees. So if I subtract off 133 from both sides, that leaves x to be, let's see, that's 7. That's 7 for 47 degrees. Okay. Here's one that throws a little bit of a wrench in it, not much though, because we're just kind of combining some stuff. So if you're kind of having trouble seeing this, you can go ahead and draw on the central angle. That might help. Please recall that the central angle and this inscribed angle have a relationship where 64 is actually half of this guy. So 64 is half, that makes this 128. And then we're back into our normal relationship. 128, that central angle, plus the value of x has to equal 180 degrees. So if I subtract 128 to solve for x, x is going to be left to be 52 degrees. Okay. Let's change that. Okay. So again, straightforward kind of relationships. You might be seeing this directly because you kind of remember it. If not, draw on that central angle. That might help, and then step it down. 154 degrees for this arc is the same thing as this central angle, so that's 154. The measurement of z, or the angle at z, I should say, is half the measure of the central angle because that's the relationship between the inscribed and the central. And so z is equal to half of 154. Looks like a 30. Okay, so z is equal to, let's see, it's equal to half. So that'd be, what, 77 degrees? Yeah, 77 degrees. Okay. We can do the same kind of thing here. So consider there might be a central angle. In this case, it'd be 120 degrees because it shares the value of the arc. So k is equal to half of 120. In that case, k is now equal to 60. Now, if you're seeing this without drawing in the central angle, that's awesome. It's just a tactic you can use if you're kind of struggling, because everything kind of runs through that central angle anyway. All right, we have to write the equation of a circle described below. So please let's recall first the general equation of a circle. So we have x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now do recall that the h and the k define where the center is. So the center itself is at h comma k. So when you're moving this around, please understand that you have this the negatives are in play here. So like the formula of the circle subtracts h and k, but that doesn't make h and k negative. H and k, remember, is that return vector to get back home. So they're naturally negative in this case. So the tactic I think I'm going to take with these problems is to figure out where the new center is and then rewrite the equation. So instead of trying to figure out like if I shift left or shift right, like what happens with my number, I'm just going to focus on what the center is and then I'll write the new equation from that. Allow me to demonstrate. All right, so if we shift up 3 units and shift left 5 units, and we're assuming that we're starting at 0, 0, by the way. If we shift left 3 units, shift up 3 units, left 5 units, that puts my new center at -5, 3. So if my new center is at -5, 3, because if we shift left from 0, 5 are negative, and then up 3 is +3. My new equation should be x plus 5 squared, y minus 3 squared is equal to 36. And I'm getting 36 because of r squared. Remember, it's just a Pythagorean theorem, so we do have to square the radius. And so 6 squared, of course, is 36. Okay, so radius of 3, but here's the important part. We shift down 8 units. And so that means it's going to be -8 for the y. We shifted left 2 units. That's -2 for the x. And so my equation is going to be x plus 2 squared, Y plus 8 squared is equal to, in this case now, 9. Right, if we shift up 7 units, that's going to be a plus 7. If we shift right 3 units, that's going to be 3. So my new equation is going to be x plus, x minus 3 plus y minus 7 equals radius of 2 gives 4. Okay, so we shift down 6 units, so that's going to be a minus 6 on the y. Left 4 units to be minus 4. So our new equation is going to be x plus 4 quantity squared, y plus 6 quantity squared, and now we have 18 squared. Now, I don't know what 18 squared is off the top of my head, and I can certainly type into a calculator if I want. But it's actually perfectly simple. Just leave your answer as I just left it here as the unfinished calculation. In fact, in a lot of cases, it might be easier to do that, especially if you're going to be graphing. Radius of 9 shifted up 5 units, right 9 units. So that's right 9 units, up 5 units. My equation is x minus 9 quantity squared. So we have y minus 5 quantity squared is equal to a radius of 9, which is just 81. Because again, we have to square radius. Alright guys, so that's, I think, the last of circles. Looks like we're attacking 3D next for the next couple of pages. Thank you for persisting. Keep working hard, guys. I'll see you in part 9.